Now that we have practiced finding position from velocity, recall the relationship between velocity and acceleration. How would you go about finding an object's position if you were given its acceleration instead of its velocity? Well, since acceleration is found by differentiating velocity, you can work backwards and integrate acceleration to find velocity, and then from there you could integrate again in order to find the position function. So if you're given the acceleration as a function of t, you could integrate a of t with respect to t in order to get the velocity. And similarly, if you integrate the velocity with respect to time, you'll end up getting the position function. Here's an example. A particle moves along the x-axis so that at any time t being greater than or equal to 0, its acceleration is given by a of t, which is equal to 6t plus 4. At time t equals 0, the velocity of the particle is -6, and its position is -17. We're going to accomplish these three tasks. First one, find v of t, the velocity of the particle at any time t being greater than or equal to 0. Then we're going to determine for what values of t that are greater than or equal to 0 is the particle moving to the right. And then we are going to find s of t, the position of the particle at any time t being greater than or equal to 0. Let's get started. Let's start with the first part. Find v of t, the velocity of the particle, at any time t being greater than or equal to 0. Well, we're provided with the acceleration function. So in order to determine the velocity function, we first have to integrate a of t with respect to t. So if we substitute 6t plus 4 in for a of t and then integrate it, we will end up having 3t squared plus 4t plus c. The next step is to determine the value of c with the given information. It tells us at time t equals 0, the velocity of the particle is -6. So if we substitute 0 in for our t values and still have the plus c there and set that equal to -6, we can solve for our c value. So the 3 times 0 squared, that goes away. Same with 4 times 0, that goes away. So we have simply that c is equal to -6. And once we have that c value of -6, we can easily substitute it back into our velocity function in place of c. So therefore, v of t is equal to 3t squared plus 4t minus 6. Now let's look at part B. For what values of t that are greater than or equal to 0 is the particle moving to the right? Well, when a particle is moving to the right, its velocity will be positive. So if we use a graphing utility, we can graph the velocity function that we just found. So if we bring up a graphing calculator and then go to y equals, and then put in there 3x squared, or you can put it in terms of t, plus 4x minus 6. And then if we graph it, we can see that we have this parabola and it's intersecting twice. However, our function is only valid for t values being greater than or equal to 0. So we're really taking this left half and ignoring it. And if we look at the right half, the velocity is negative at first, and then it becomes positive right about here. It's really close to 1 second. In order to find that exact value, we can go into calculate, which is second trace, and then choose the 0 option, option 2. And then we can go to the left of where it crosses, to the right of where it crosses, and then guess in the middle. And it tells us that this 0 is at about 897 thousandths of a second. So for any t value greater than 897 thousandths of a second, the velocity will be positive. Now let's look at the last part of this example. We're asked to find s of t, the position of the particle, at any time t that is greater than or equal to 0. Well, we have the acceleration and we found the velocity. The velocity function is 3t squared plus 4t minus 6. So in order to find the position function, we are going to integrate this velocity function. And we're going to integrate it with respect to time. And if we use the power rule for integration, our first term will become t to the third plus 2t squared minus 6t plus c. And then similar to one of the last questions, we can actually solve for this constant value c because it tells us that when our time is 0, the position is negative 17. So if we substitute 0 in for every variable t and include the plus c and set it equal to negative 17, we can end up solving for that c value. It ends up being that c is equal to negative 17. And the final step in solving this problem is to rewrite our position function with minus 17 at the very end of it, making it be t to the third plus 2t squared minus 6t minus 17.